And so the next ones, we're still solving exponential equations where we've got variables in the exponents, and again, we can't make the bases the same, so we're going to again just do the log of both sides since we don't have a base of e. So I'm going to say that I have the log of 17 to the negative x minus 3 equals the log of 16 to the negative 8x. Now that it's in logarithmic form, we can move our exponents out in front on both sides. So we would have negative x minus 3 times the log of 17 equals negative 8x times the log of 16. Now on this one, since we have x's on both sides, it's probably better just to go ahead and use the distributive property, because if I divide by the log of 17, I still have the x with this one. So I'm just going to use my distributive property first. So negative x log of 17 minus 3 log of 17 equals negative 8x log of 16. Want to solve it for x, so I want my x's on one side of my equation, anything without an x on the other side of my equation. So I'm going to move my x's to the left and my other thing to the right. So I'm going to have negative x log of 17. I'm going to add my 8x log of 16. Then I'm going to move that over to the other side, so it's going to be a positive 3 log of 17. Did that so that I could factor the x's out of my two terms here. So if I take the x out, I have negative log of 17 plus 8 log of 16 equals my 3 log of 17. And then to get the x by itself, I can just divide by all that stuff in the parentheses. So x is going to equal the 3 log of 17 over all the stuff in the parentheses, so negative log of 17 plus 8 log of 16. And here they say write it using exact answers, using base 10 logarithms instead of finding the answer to the nearest hundredth. And so we don't even have to punch that one into our calculator. We just get to leave it in this form right here. So number 8, same kind of thing. I want to solve that for x. I have bases that I can't write the same, so I go ahead and do the log of both sides first. 7 to the negative x minus 7 equals the log of 9 to the negative 6x. I do that so I can move my exponents out in front. So negative x minus 7 times the log of 7 equals negative 6x times the log of 9. Go ahead and use my distributive property here. So negative x log of 7 minus 7 log of 7 equals negative 6x log of 9. Want my terms with the x's on the same side, I'm going to move them to the left. So negative x log of 7, I'm going to add the 6x log of 9, and then I'm going to move that over so it becomes positive 7 log of 7. So I have my x's both on the same side. I can factor out my x. So I have x times negative log of 7 plus 6 log of 9 equals 7 log of 7. And then my last step, dividing by all the junk next to the x. So x is going to equal 7 log of 7 divided by negative log of 7 plus 6 log of 9. So number 9, what should I do first on that one? Log of both sides. So log of 13 to the negative 6x equals the log of 3 to the x plus 5. Move my exponents out front, so negative 6x times the log of 13 equals x plus 5 times the log of 3. Use my distributive property to get rid of my parentheses, so negative 6x log of 13 equals x times the log of 3 plus 5 times the log of 3.
Subtract your x.
Move my x over here, so I'm going to have negative 6x log of 13 minus my x log of 3 equals my 5 log of 3, right? Then I'm going to take out the x. Negative 6 log of 13 minus the log of 3 equals 5 log of 3. So x is going to be equal to what? X equals 5 log of 3 divided by negative 6 log of 13 minus the log of 3.